What is vector database? How do we use it? Good day guys, my name is Melvin Satishan. Today we are going to discuss about vector database. A vector database encodes information as a vector in a multi-dimensional space. Vector is a list of numbers. Let's consider a classic example here. So we have a person sitting at Newark city and the other person sitting in Germany, Berlin. So the geographic location pertain to this person A is 1030 and the geographical location pertain to the person sitting in Germany is 4070. Let's say that the graphic geometrical data. So a person wants to travel from Newark to Germany. So the Newark is tail and Germany, the destination is going to be head. And the distance in between this two person, I mean the Newark and the Germany, is called magnitude, right? So how do we calculate the magnitude? By considering this source or a tail and considering the head. So the difference between this is called magnitude, right? So this is what is happening in the vector database as well. Let's consider another example. The person who is sitting in the US, Newark, and the person who is sitting in Germany and let's say Berlin. So in this we have provided only two parameters, right? The x-axis and y-axis. Let's give more patterns like a x-axis is 40, y-axis is 70. Then for Germany we are giving some other numerical code. Then in the Germany state, let's say that Berlin, we have provided some other numerical codes, right? So altogether it will become a list. That list we will be saving it into a database. Similarly, in the US also, we will be providing the country code, state code and the location code together so that this will become a list of numbers. That list will be saved in the database. Now, when I query a particular value, it will first reach out to the database and it will check whether there is any similarity. Suppose my query contains a particular value called 40 and 70. In that case, this is very close values, right? So that it will be listing the person who is sitting in Germany. Suppose I'm querying for a person whose x-axis data and y-axis data is 10 and 30 respectively. In that case, I'll be getting a person who is in the US. Or as we told that here we have a country code, right? If my query is related to a country code, in that case also this person will be listed in my queries response. So that way we can easily fetch the data. That's the application of vector database. Let's consider another example. We have a biomedical farm. They are collecting the chromosome or a gene related to a cancer patients. Let's say that they have collected 100 millions of or 10 million of cancer patients across the globe and they have saved it in their database. And they need to do a system, a proper study on that. Let's say that they are collecting the gene from some other newborn babies and they want to predict that whether this genes are having some problem with this or any similarity with this diseased genes, or do we need to do something in that case. Those areas we can use this procedure, right? Second is fraud detection. Let's say that you are getting an email some phishing email in your system, so you will immediately report. You will select in your Outlook. You will select the phishing reporting. So it will go to your uh, directory services team or exchange services team's centralized database. This email will be sitting. Similarly, with assume that a million employees are there in your organization. Everyone is reporting this similar issues. They will have a very vast database. So what will happen is they will implement an AI system that would be able to detect phishing mails. Whenever a mail is landing into our inbox, it will go and check whether similar pattern is available in your quarantine folder or not. If there is a quarantine folder and inside the quarantine folder a similar pattern of email is identified, in that case automatically we can mark this as a phishing email. That would be the second. That's a fraud detection, right? Similarly, we are doing some financial transactions. In that case, we will be creating a separate repo for identifying all the fraud transactions. So the existing, whatever the ongoing transactions, will do a comparison with uh, the list of transactions in the fraudulent repo. So if there is any similarity, automatically we will cut the payment gateway and make sure that the customer will not be losing the payment, right? The next option is image retrieval. Assume that we have a centralized database, a passport verification database. In that case, a person's a face image is already saved, or a biometric is already present in their centralized database. So this person's skin tone or the iris unique IDs, each and everything is saved in the form of numbers and a list of numbers in their centralized database. The moment when he stand in front of the scanner will automatically scan his face and it will convert it into the form of vector list, right? So this list will be comparing with the backend database. If they are able to detect a particular pattern, then it will list out the list of persons, right? So from that we would be easily identify the person. So that's another application, right? Now, so being said that this is a 5 use cases with the vector database. Now, why are we using the vector database? Let's say that we are doing a small factory. We are running a small factory. Inside the small factory, we have 100 products. So each product we have a cooking recipe and its health benefits and its additional modifications, details and ingredients list, right? So these all are our secret recipes. Now we are asking a question to our chatbot stating that, okay, can you list a particular, can you prepare a recipe for a particular product? As we have already discussed, the large language model is already a pre-trained model, right? So it is already having a parameters, patterns and artifacts. It will be doing the permutations and combinations in the behind the scene, and it will check what are all the details inside its repository, and it will provide us the output. Since our recipes and our factory details are confidential and we haven't taught to this LLM system, it won't be able to provide us the accurate data. Rather than that, it will provide us the data what it knows, right? In that case, we will get a false information. Now, how do we teach our LLM about our factory products and the product details. For that, we are using vector database. What we do first, let's say that we have a million of documents, right? This million of documents, we will be ingesting it into a vector database. How do we do that? First, we will convert this each document text in the form of chunks. That's called reading and pre-processing format. Next, we will convert these chunks into an embedded system. So the embedded system will embed each and every chunks in the form of embeds. Then this each embedded chunks will be vectorized, in the sense a whole document we extracted the text, then we make it as a small chunks. That chunks we will be further converting in the form of numerical values, a list of numerical values. This list of numerical values we would be saving in our vector database. On the other hand, our data will residing in the storage. Whenever we require to fetch the data from the storage, we can just like that query the matrix or the parameter pertain to that particular data block that can be retrieved from the database, so that we would be able to retrieve the document. So this is what is happening in a vector database. Now let's do a practical scenario to practice how the vector database works, so that we will be understanding the concept. So for that, we have to install ChromaDB. So how do we install ChromaDB? It is as simple as pip install ChromaDB. Okay. So here we have installed the ChromaDB. Once we have installed the ChromaDB, our next step is to initialize the ChromaDB. For that, we have to do client equal to ChromaDB import ChromaDB. First step is importing the ChromaDB. Second step is initializing the ChromaDB. For that, we can do ChromaDB dot client, right? So we have ChromaDB client now. Our next step is we have to create a collection. So for that, collection equal to client dot get or create collection, and here what we will do, we have to provide the collection name. Let's do this way. Collection name equal to chroma underscore practice. Okay, I have provided the chroma underscore practice collection name, and that collection name I have to mention it here, right? So it is intact now. So let's execute this. So our collection is ready. Next is documents. Let's create a sample documents. Okay, the sample documents can be a list of a dictionary. In that, we can provide a document ID. It can be a string. Let's say that document 1, and it should have a text format called let's say that Sun or Amazon is a good service provider. Okay, provider. Amazon is a good service provider. First document. Okay, next, here we will define the ID again, and we will mention that document 2, and here we will mention the text as Azure directory services are popular. Okay, next is ID, document 3, text is going to be Kubernetes is an orchestration tool. Okay, so we have 3 documents in this array. So now our what we are going to do is we are going to ingest this document into the collection, right? So for that we are going to do for document in documents, right? So what we can do is collection dot add, and it will take these parameters basically, right? So document equal to document, because in this document we are doing the iteration on each and every parameter, right? So in this document text, right? Next is IDs equal to ID. So for that document ID and document text, this will be the value, right? Now what we will do is collection add. Okay, very nice. Okay, so let's do here, there is a small typo, documents it is. Okay, inside of existing embedding, because it was already ingested it, right? So what happened is this command is successful. We have already ingested this 3 documents, right? Now what we are going to do here is we are going to query the document. Okay, so for that response equal to collection dot query. So let's see the parameters. What are all the parameters? So here we have a parameter called query text. It is called query text. Query text. So in this, what we will be giving the query text. So for that, let's do this way. Query underscore text equal to Azure. Okay, so we will define this value here, Azure, and then we will print the response. Okay, if you look at it here, we have total 3 documents and we have here embeddings none, documents, Azure Directory Services, Amazon Directory Services. It's a good, right? Now we have a metadata, and here we have a distances. So if we look at it closely, we have a parameter called IDs, the document 2, document 1, document 3, right? And in the documents, the values are coming like a document 2, right? The document 2 is document 3 here, because in an array it starts with the 0. So 0, 1, 2. So document 2 is listed here, document 1 is listed here, document 3 is listed here. Okay. In this we have a documents. So Azure Directory Service is popular, Amazon is a good service provider, Kubernetes is an orchestration tool. Now if we look at it in this document, if we look at it, the first is having 0 distance, which means 0.8, which means it is very close to this string. Our query is very close to this string. Whereas Amazon is a good service provider and Kubernetes is an orchestration tool. Our query parameter Azure is not present in these two strings. That's the reason the vector value is 1.29581636, right? So what we need to tell you is, assume that you are providing a value which our LLM doesn't know, then the LLM will provide wrong information. It will provide you what it knows, else it will land into a state called hallucination. It may provide you a false information. So that we need to teach an LLM. How do we teach the LLM? We will be loading our documents, and that documents we would be loading it into a vector database. Now this vector database, once we have created the vector database, the query should go and whenever we would be querying, the query should do an embedding. The query itself will be sliced into chunks, then it will do an embedding, then it will go and search in the vector database index. Once it received the query, then that query will go to the large language model. From there it will do the augmentation, and it will provide or generate the desired response. So that currently our large language models knows about our confidential project and its recipes, so that without sending this to the outside world, within the context itself, and we have defined the context that you just specifically look at our project, and from the project you just provide us the data, so that we will get the accurate response. So that's all about the ChromaDB in a 10,000 feet overview. We will see you in the next lecture, where we will deep dive into the RAG concept. Thank you for watching. Have a great day. Bye bye guys.